Hi, my name is Rohit. I'm one of the authors on this paper. So here we build a system where a series of machine learning models learn from each other to ultimately be able to design optical structures that will respond to light in ways that we want them to. So machine learning models, especially for complex tasks like this, require a lot of data, and even slight changes in what you want them to be able to do can sometimes require training a brand new model from scratch, which then requires even more data. So solving this data issue is a big challenge, especially if you want to be able to build a really complex model. So we introduced this nested strategy where we train a very simple version of the structure first, and then transfer the knowledge from that first very simple model that doesn't require a ton of data to a slightly more complex model, which will only require a small amount of data, and then so on, gradually increasing the complexity. And each step, it's storing more and more knowledge that we represent here with the kind of increasing blue weight connections as the training goes on. So this is able to, again, inversely design optical structures that will basically respond to light at all of these different wavelengths the way that we want them to. So this is an example of where we want the structure to be able to closely match this blue curve as closely as possible. You can see that our model, after this nested training, is able to get a very close match at almost every wavelength. And then the same holds true even when we go for significantly more complex structures that have real-world applications. So the structure here, the blue curve, is a very kind of idealized curve that would be very difficult to realize and find a design that matches 100% for. We were showing that for this type of structure that can be used in photovoltaic cells for things like solar energy, we want the structure to be able to absorb light as much as possible below a certain critical wavelength, and then not absorb as much light beyond that. So this would normally be a kind of thing that takes a huge amount of data to be able to closely match, but we're able to get something that's even more efficient than some of the current best performing structures for this type of application using this nested knowledge transfer strategy that we show here. We hope that this can just be a first step to building out even more complex things and finding new designs that have even better performance for important applications. Thank you.